Hello, everyone, and welcome to episode 15 of Nutanix Weekly. I'm your host, Andy Whiteside. I've got Harvey Green with us. Harvey from XenTegra is on time. Hey, Harvey, how's it going?
I am good.
That podcast I did earlier today, did you mean to pop into that one, or did you think you were heading into another one?
I thought I was headed into a different topic, but it was fine either way. I coordinated with Randy because he told me he was jumping on there, so we were gonna kind of bum rush you and give you a surprise, and he never made it, so I let him have it afterwards.
He said jump, and then he didn't jump, and you did.
Right.
We got Jirah Cox with us. Jirah is always a staple here. We call him a co-host for Nutanix Weekly. Jirah, how's it going?
Good, man. Every podcast is improved by sprinkling some Harvey on it. So
he just jumps right out of the bushes at us occasionally. I may not be up top of my game. I think I told you guys why a few minutes ago, but hopefully we'll get through it. Kees Baggerman. Kees, how's it going?
Hey, thank you for the invite. Everything's fine here. Thank you.
You got a blog from earlier in the year, Nutanix and AMD break the user density bottleneck. That's why we have you on here, but you're a legend in our space. It's like I try to tell my kids I'm famous with a bunch of IT guys, which isn't necessarily true, but it's kind of true. And we go somewhere once in a while and people will start talking to me out of the blue. Happened in Puerto Rico a couple weeks ago, and you very much have a brand, and people know you throughout the country, especially as it relates to end user computing and then Nutanix. Give us just a little background on yourself.
So when I explain what I do to my kids, I just say that I failed a lot, and because of that, I've got a lot of experience in how not to do things. So that's kind of my angle. I don't like to call myself an expert other than failing, which I did a lot when I started like in the IT. I actually so when I was a little bit younger, I wanted to be a archaeologist. And then it turned out that there's not a lot of money to be made there. So I went and studied commercial economics, which obviously involves a lot of money. So that was an interesting kind of segue from that. During that kind of period of time, I actually got introduced to computers. So I was kind of laid into all of the home computers and internet and all of that. I was like 18 or 19 when I got my first computer, in very very distinct towards others in our industry who have been born and raised with computers. My parents they weren't even closely interested. So when I got access to broadband and computers, I started to fumble around. I started off at a help desk for a internet service provider. And somehow I just grew into it. So after getting my bachelor's degree in commercial economics, I started to work for I did already work for that service provider, and then just moved on to sysadmin roles, but always on the partner side. So I never worked for an end user or the actual end users, but always as a partner, working at system integrators. Did a lot of SMB like configurations, and just to kind of level set, SMB in the Netherlands is like very, very small. It's like somewhere between 0 and 500 computers, right? That's kind of what our SMB looks like. And quickly after like 2.5 years, I was growing into that role, moved on to a more senior role. And after automating everything in the actual process of our deployments, I figured it was time to kind of do something else and move on to something bigger and bolder. And that's when I started with my previous employer. Spent there about 5-6 years as a solution architect around end user computing. So that's when I got in touch with Citrix technologies and VMware technologies, and your native Microsoft technologies as well. And fast forward 6 years, or actually 6 years back, because that's how long I've been with Nutanix now, 6.5 years. There was an SC called Raymond Epping, and he's one of the first SCs in EMEA. And he's actually a close friend of mine. And he told me about this company, and I had to look into it. And I actually did that as an addition to our portfolio at the time. And I guess I made an impression to him because a few weeks later, he asked me if I wanted to join Nutanix as an SE. Funny story, I got declined for that role. They hired somebody with more experience, and I'm lucky enough to say that I'm happy to tell you that they hired Martin Boschart, who's still with Nutanix, great guy. And 2 weeks later, there was a role in the performance solution engineering team that came open, and that's when actually the kind of the aha moment was there, and that role kind of fitted me more than the SE role. So that's how I joined Nutanix. And now, fast forward 7 years, I'm a technical director for end user computing within Nutanix.
Yeah, that's quite the story, and pretty much the way I understood it. I mean, anytime I talk to someone about, let's say, Citrix or Horizon and Nutanix, they always bring your name up as the expert. And I didn't know who you were, and I got on a call with you a couple of years ago, and you did a really good job and made it clear that you do know this space, and you've probably only just grown and grown ever since.
I kind of don't trust anyone in IT who doesn't do a stint at the help desk. It's just such a trial by fire.
I think we talked about it a few
Absolutely.
weeks ago. There's those who have been grown up talking about it, and there's those who grew up doing it, and you have a whole different perspective. A lot of people in the current generation get to go straight into just talking about it. I was with our college grad student last night, college exchange student, and it was encouraging to hear him talk about how he wanted to go get a job and learn how to do this stuff versus being entitled to just walking in and running the place.
Well, the one thing that I learned at working at that service provider was, breaking down the problem. Go back to the basic foundation and then move on. And that's kind of how I work now. If I run into issues or if I run into problems, I'll just break down the complexity and start with simple, and then start adding components to make sure that everything works the way we think it should work, and then find the issue and then fix that, instead of taking that whole bulk of issues and just trying to figure out what's going on there.
Right. Yeah, it's kind of a basic math problem, right? You got to do the basic math within the problem first, and then as it evolves, hopefully the answer becomes clear.
Exactly.
Yeah, when you can tell when someone has really felt the effects of, like, I misconfigure this and 100 phones all start ringing at once. Like, that person is motivated to do a good job for you.
Yeah.
Well, let's jump in this vlog. We'd never get through it at this rate, the way we kind of just talking, which is great. I mean, there's we could probably just do a podcast just chatting about the EUC space, which ends up being a lot of what Harvey and Jirah and I do when we're talking about these Nutanix topics, these blogs. But let me go ahead and read the title again. It says Nutanix and AMD break the user density bottleneck. The focus shifts to meeting business requirements where it should be. This is interesting for me because I was on a call the other week with a customer we were scoping out Nutanix for. I think Lenovo is involved with this one, and he specifically requested AMD, and it was a kind of for me, it was a moment where I had to think about, is AMD back in this? And apparently they are back in a big way. I think, Kees, you're gonna help us understand that. Can you kind of just give us the intro that you're covering here in the blog?
Absolutely. So when I look at end user computing, there's a couple of metrics that I think are important. And obviously, disk latency is important because that kind of adds to user experience, disk capacity in terms of network capacity. Then there's RAM, and then there's CPU. Kind of those four items, and there's a little bit of GPU as well, but let's leave that out of the equation for now. But in a generic desktop or virtualized app, these are the things that I think matter. And if you look at the way Nutanix has been architected, the first two are actually no longer an issue, right? So what we've done with our distributed storage fabric is take away all of the complexity around disk latency and capacity, because it provides low latency access to the storage layer, and thus delivering that excellent end user computing or user experience. If we look at go ahead, Andy.
The first two, how much of that is just pure horsepower that we have today with M2 and SSD drives, one or the other or both? How much of that is intelligent software?
So that's an interesting topic you bring up there. We tested hybrid systems. So if you look at our reference architectures, in which we kind of describe how you would or could design a end user computing environment on top of Nutanix, We typically test with hybrid configurations. And with hybrid, that means spinning disks with SSDs, right? So that's kind of our go-to system. And we took that kind of same test methodology and put that on all NVMe drives. The difference is about 0.2 milliseconds latency. So that's a hybrid configuration versus all NVMe, and it only brings 0.2 milliseconds improvement in terms of latency. Now, is that even noticeable for the end user? Probably not, because there's something that we call protocol round trip times. Because if you look at the way that the end user interacts with their desktop, it means that they're sitting behind a device. When they click on an icon or when they open up an application, it takes time for that task to execute on the remote system and come back again. And that's what we call protocol round trip times. So the protocol round trip time, in my case, HDX RTT or ICA RTT, is about 10 to 50 milliseconds. So that 0.2 millisecond storage latency that we're taking away by using NVMe isn't actually noticeable by the end user because of the round trip times.
Right.
So all in all, to your extent, Andy, I think yes, partly it's because of the newer storage technologies that will allow you to have better user experience. But also, if you look at scalability, that's where Nutanix has a play. That's where our software has definite added value, because we're utilizing data locality as a default versus other solutions that won't have that. So if you scale up to hundreds or thousands or maybe 10,000s of users, you'll have that same concept of data locality, which helps in that overall end user experience.
So here you're talking about the four ones that most people think about, but then you bring up some other key issues to think about. And your next one is reduced complexity. Why does this matter?
So if we look at the complete stack so if we break it down high level and we look at the items that we need for a decent end user computing architecture, there's a lot of moving objects, right? So when VDI was introduced, there was a demanding kind of, or the more demand for that lower disk latency and higher disk capacity. And we saw band-aids popping up. So MCSIO, PVS RAM cache, or float to disk, VMware's VSA CBRC, but also kind of point solution like the former Atlantis, right, where disk caching was kind of solved by the storage solution by itself. Now, all of that is basically not necessary if you pick the right storage based foundation, and that's again where Nutanix has its play, even using hybrid systems. Now, so we're taking away components, and I've always been a big fan of keeping things simple. So if I can remove something from the architecture without breaking functionality, I will. So if I look at a very simplistic solution, the less components it has, the less things can go wrong. Right. So taking out, for example, PVS RAM cache or PVS by itself, because that's a separate infrastructure you need. If I can take it out, it can't break.
So your guidance here is, figure out the way to reduce complexity, and then work towards making that less complex system as fast as possible.
And again, I think that Nutanix gives you the foundation to bring all of that simplicity, right? It's not just management of our stack, because that's that simple. We've made it in a way that even I can operate it, which means a lot from a storage perspective, right? I'm not a storage guy, but I was able to figure this out in a few minutes. If you're able to do that and take away the focus on keeping the lights on, because that's what the system is doing for you, you can actually focus on what's important, and that's the end user. Right. So you can sit next to the end user, talk to them, do interviews, be on the floor with them, and see how they work, how they operate, and what they do. Because sometimes, end users do, surprising things that we don't see if we're designing this in our own offices.
It's really powerful, right? Like for our audience here of Nutanix customers or potential customers or Nutanix sellers on either the Nutanix side or the partner side, like no proposal exists in a vacuum, right? There's always us versus something else normally. And it's not that something else doesn't work, but why have more band-aids in the stack when you could have fewer band-aids, right? And I think that's amazing. It's powerful about it's not there, so it can't break.
Right. Harvey, thoughts on this? I know you're a big Nutanix champion when it comes to end user compute, specifically simplistic MCS in a Citrix world as an example.
Yeah, I mean, there are already things that are built into the stack, and to Jirah's point, these things are already in there. They're built in. They're not band-aided in, so you don't have to worry about your duct tape falling off. We are all in the business of cobbling a bunch of solutions together. Some we get to choose, some we don't. But if you can make it so that your job is easier by taking out the possibility that there's all this duct tape and band-aids, then you should absolutely do it. As I've said, many times before on the podcast and to customers, is Nutanix for your sanity. Like, stop going around and making yourself go crazy because you have all of these things that you're trying to, duct tape and super glue and all of that together just to try to make some things work, when you've got an option that takes that away from you and just makes it so that it's a lot more seamless and it's built in, and these functions are tested and they worked they were built together from the ground up. So they're not trying to put lipstick on a pig here just to make some things work and say they're checking a box for features. So
one of my favorite and least favorite things I've experienced in this space is, you introduce somebody to Nutanix and this distributed file system that we're going to talk about here in a second, and they don't want to hear it because they're a 3-tier architecture guy and they're too smart for this. And then
right,
a year or two later, they introduce me to Nutanix. I'm like, wait a minute, did not introduce you to this a couple all of a sudden it's a good idea because it's theirs. That's always a lot of fun. Kees, you want to jump us into this next section where it starts to talk about innovation and your storage, distributed storage system?
Absolutely. So I mentioned before that the Nutanix distributed storage fabric basically takes away a lot of the complexity of that legacy 3-tier environments. And if you think of it in a holistic approach, basically we're aggregating a bunch of disks in a certain cluster or a group of servers that we call a cluster, and presenting that as a logical storage pool. Now, what we do with our storage fabric is obviously ILM, which allows us to move hot blocks to faster tiers and cold blocks to slower tiers, and thus keeping a balance between capacity and performance. And in all fairness, we've evolved in that as well. So where we formerly had set configurations of 2 SSDs and 4 spinning disks, you can now do that hybrid configuration. You can do all flash, so only SSDs. You can do partially populated if you need less storage, which we probably see in kind of the VDI and user computing space. But you could also do NVMe with SSD or all NVMe. So there's a lot of flexibility. And from a consumption perspective for customers, it's similar. It's all similar. So it doesn't matter for us kind of which storage layer you have underneath it. We'll fix that for you and do the automated tiering if need be of your data. Now, one of the golden nuggets that we have, and I mentioned it before, it's data locality. And especially in a MCS or link clone or even instant clones, if we're talking VMware perspective, what you would typically see is that you would have a golden image, and when we're spinning up machine catalogs or desktop pools, we'll see different VMs being created. That VM will have a differencing disk and an identity disk. That identity disk is always static, doesn't change, and this is MCS specific. VMware does something similar, but I'll keep it with Citrix for this example. So there's an identity disk and a differencing disk. Identity disk is always the same. It's 60 megs, won't grow any bigger. And then there's a differencing disk. The differencing disk is where all the writes will go. So in a non-Nutanix environment, when I spin up a 2,000 VMs in that machine catalog, it means that all of my 2,000 VMs are reading from my single golden image. So all of my reads are traversing the network to my golden image. adding latency because it's not local, so it has to traverse the network. It's congesting my network with reads, and it's creating this read hotspot on my centralized storage. What Nutanix does is, because our storage traffic goes through our CVM, we can actually monitor the IO pattern that goes through that CVM. If we detect only reads to a VDisk or a VMDK or whatever file format you're using, we'll mark that disk as immutable, and we'll copy that into the local host, which means that we're basically creating a local read copy for every single host that we have out there. And that's adding to our scalability, or the ability to scale linearly. So that's all in our distributed storage fabric, and that ensures that reads and writes will always be local. And at scale, you'll see a tremendous or immense benefit in terms of performance, not just with link clones or MCS-based machines, but also if we're looking at things like app volumes and whatnot, where there's a kind of a link copy of that disk into every VM out there. So that's basically what our distributed storage fabric does when it comes down to end user computing. It offers data locality. So at scale, it definitely helps with overall performance if we compare it to legacy storage systems.
Yes, this is actually interesting. I was talking to some marketing folks a little while ago today, and we were talking about local versus global, and the old school marketing guy was very much into local, and I'm arguing for global access, even if it's not as good, is the way to go. But this is a great example of if you have things available to you locally, and you have the option of global fetch versus local fetch. Local fetch is going to always be the faster and win out, even though the global fetch has gotten much faster and greater bandwidth as well. Just having what you need locally and intelligence, making sure it's there when it's needed is really the story here, isn't it? Harvey, Jirah, thoughts on this part of the conversation?
No, nothing to add, right? Locality is the secret sauce for sure.
So we kind of turn our attention over to RAM, and it sounds like Nutanix has gotten smarter about making sure that is faster, more available as well, right?
Well, RAM has always been pretty straightforward. So if you look at the overall RAM usage or need, then you can just take the amount of RAM a host has, and you subtract a little bit for the CVM overhead, and typically a little bit for your hypervisor overhead, and that's a usable RAM you would have left, right? So in the testing that we've done with the AMD systems, we opted in for a terabyte of RAM. We configured our CVMs with 32 gigs of RAM because that's our default for our testing. Basically, what we saw was, on AHV, the hypervisor overhead is per VM kind of overhead, and what we've seen is about 8 gigs in total for that total number of desktops. So again, RAM is pretty straightforward. I would never advise people to do RAM overcommit because it sounds like a great feature, but when problems arise, then RAM oversubscription will probably bite you in the butt at some time, if I'm allowed to say that way.
Perfect.
So we're taking away the complexity of storage. We're adding the overall low latency storage subsystem. RAM is pretty straightforward. So the difficult part in EUC and sizing or scoping out a piece of gear for customers has been CPU. And that's my perspective. I'd love to hear from Harvey and you guys if you've seen the same kind of thing.
Well, let's help people understand that we're talking about desktops here, right? And desktops can be sitting there doing nothing, or they could be sitting there with 40 Chrome tabs and 18 applications running at any moment's notice.
You got it.
And that's where you have it depends, and that's where we need as much speed as you can possibly get us, even though we know a lot of the time we won't be using it. We're not, we're not crushing data. We're not trying to do some type of encryption algorithms constantly nonstop. But when the user needs it, they need it. And I think that's where AMD has made another leapfrog in the industry, right?
Yeah, absolutely. I mean, CPU is definitely one of the more discussed pieces when we go through sizing. And, one of the pieces, as Andy kind of alluded to, that's, we can do our best to estimate, but we have to have as much accurate information as possible. And we also know that even that information is probably not going to be the most accurate. Users needs can change day to day, but there are some overall things that, if you can get that information out to the people who are sizing things out for you, that helps out a lot. What we don't want is to end up with somebody in a CPU strapped environment and have everything else be perfect, right? Because you still have an issue.
Well, and one thing to highlight on Nutanix, you can always add more nodes, whether it's compute or storage. You don't want to have to, but
you absolutely can.
Nice things about this type of infrastructure is you can add whichever kind of Lego you need to add next. Jirah, are you starting to run into more and more people talking about AMD versus Intel?
No, for sure, right? Because CPU, it's where all the work happens, right? But some people have been doing VDI long enough in their environments that they can remember back to when like 1 CPU and 2 gig memory was sufficient for like XP running IE6, right? And they're like, they look at Windows 10 and they're like, wait, we need how much per desktop just to like let it idle successfully? And CPU is kind of the one that's changed the most, I think, there.
And even just with Windows 10, right? From our testing, again, we do a lot of benchmarking. We run log and VSI, which is basically the industry standard for load testing. We run log and VSI about 24/7 in all different configuration and shapes and formats. And even just Windows 10, from one version to another, there's such a big gap between density caused by numerous kind of items, but CPU is definitely the main change in if we look at resource consumption from those desktops. And if you just look at what 1909 did or 1903 did versus where we are today, it's between 1909 and where we are today is like a 4% delta. So that's relatively small, but we've seen deltas of 10, 12, 16%. So even just by upgrading Windows 10, which is not something a end user would probably do by itself, because that typically is a corporate decision to move to a newer release, you're impacting your overall sizing by tens of percentages. So that's a huge number. And like Harvey said, you don't want to lock yourself into a situation where you don't have enough CPU, or obviously if you're on Nutanix, then you've got the flexibility to expand the cluster with newer nodes. But sometimes you just want to keep it inside of the nodes just to have a good balance between resource utilization in terms of RAM and CPU and disk. So having AMD as an option is definitely something that we've seen as a good solution for end user computing. And all in all, if you look at the progress that AMD has made, and I'll get into the details of our testing a little bit in a few seconds, but I love the fact that AMD has brought out these newer CPUs and Intel just woke up, right? All of a sudden they were, all right, so we've got Cascade Lake right now, but we need something more beefier. We need more cores. We need higher clock speeds, because if we look at what user experience means from a CPU perspective, we probably, for end user computing specifically, we want a high number of cores, but also high clock speeds, because high clock speeds means faster applications when they're single threaded. And I know that all of us have been dealing with single threaded applications since day zero, since the birth of VDI. So finally, we're at a point where we're able to get, like from an Intel perspective, to be getting like 20 core CPUs with at least 2.7 gigahertz of clock speed. So the whole push from AMD with these newer CPU releases, they're also pushing Intel into innovation and all of that. So I love the fact that AMD has been picking up basically picked up the gloves and said, let's bring it on, Intel.
Yeah, competition improves the breed for sure, right? And
Absolutely.
even for server virtualization, right? Usually the first constraint we hit or solve for, or is the long pole in the tent, would be cores per node.
Right. Yeah, but we've kind of seen AMD and Intel leapfrogging each other forever. They'd kind of gotten static, and it seems like those CPU wars are maybe back, right?
Yep.
Okay. So, Kees, help us understand what the system that you got and you tested with looked like. Looks like it's from our friends at HPE, and then kind of what the testing workloads look like.
Absolutely. So I already explained that we're using login VSI as our benchmarking methodology into our lab. The gear that we have is DX 385s, which is basically kind of your DL 380, but the AMD version. So it's the DX 380 is kind of the Intel version. The DX 385 is the AMD specific machine. We used EPYC 7542 CPUs with 2.9 gigahertz of clock speeds. So these are 2 times 32 core CPUs, so a total of 64 CPUs, physical CPUs, with a clock speed of 2.9 gigahertz. We have 1 terabyte of RAM. These machines were in a hybrid configuration, so 2 SSDs and 10 spinning disks, loaded with AOS 5.19, running AHV, Nutanix AHV, our own built-in hypervisor. And in this case, the kind of the foundation of this blog post was CVAD 1912 update 1, and we tested with MCS PVS, with Windows 10, Windows Server 2019, in all these configurations. We tested knowledge worker profiles because that's our basically our go-to standard, but we've also tried to work with power workers as well. And what we typically do in all of our testing, if you look at our reference architectures as well, you'll find that we'll start off with 1 node testing. So see what the maximum number of users is on that particular configuration, and then move on. And it was very interesting to see, because when we ran the first single node test, we actually had to scale down RAM because we weren't pegging out the CPU, which was a first for us, right? So we used Windows 10 1904 with 2 vCPUs and 4 gigs of RAM, and we noticed that we weren't pegging out the CPU, so we lowered the RAM to give more headroom for more VMs. And with that we got to a a successful test of 360 VMs knowledge worker profile on AOS 5.19 with AHV with CVAD 1912 using MCS. And when we tested 360 users, we got to 336 users. Mind you, that was the VSI max. So if we look at login VSI, if I take a step back and we look at login VSI, it basically delivers 2 important metrics. One is the VSI base, and the other one is VSI max. VSI base is user experience. It measures a threshold, and anything below 1,000 is considered as really good by login VSI. And in our first test, we got to a VSI base of 758. So that's well beyond, or well below that 1,000 threshold that login VSI gives you. And that's with MCS, and we got through 336 desktops. On our second test, we were using the same configuration, but PVS, and we got a VSI base of 732 with 337 desktops. This is a single node test. So with this test, at 100% CPU capacity, we got 336, wow, 337 desktops on a single node. And that just blew my mind, right? That's just an insane high number. That shows you that we had so much horsepower in those systems. That being said,
Kees, before this test, what would you have said in general people should get per node?
It really did, and it's a consultancy answer, but it depends. But if you look at so one of the systems that we have in our lab is an Intel Cascade Lake CPU. It's the not the refresh one, but before the refresh. It's 2x18 cores at 2.2 gigahertz, and depending on your configuration, you get about 100, 150, 160 desktops if you're cranking it. So this is almost doubling that amount of, or that's more than no, that's doubling that amount of users.
Yeah.
Which was insane.
I was going to say 150 would be a huge stretch, and then when I realized what you were pointing out here above 300, I had the same reaction you did.
Yeah. Well, and Kees, stop me if this is getting ahead of myself, but like what in general, I know it depends. What do you like for like a pod based boundary, like 10,000 users per pod?
It depends on the brokering configuration you have. For VMware, there's a pod architecture, so I would align to that. But if we look at CVAD or Citrix Virtual Apps and Desktops, typically I'll build out either 5,000 or 10,000, depending on what the customer wants, and move like that. So it's breaking it down, and that means that we're becoming more and more, we're taking away barriers for the infrastructure, and I'll get to my to the point that I wanted to make later on. But if we're looking at kind of the next kind of testing that we did, we actually moved from 2 vCPUs to 3 vCPUs per desktop, because we noticed that we had a lot of horsepower, and all of our testing in our reference architectures is at about 80% CPU utilization. That's because we want to protect people from running 100% CPU capacity. So if you look at our reference architectures, they're always benchmarked at 80%. And that's what we did in our second kind of set of tests as well. So we took the number of 235, again, knowledge worker profile, AOS 5.19, CVAD 1912, update 1. Our VSI base was 711. So again, way below the 1,000 that is still considered as good. So this is very good. And the VSI max wasn't reached. And with PVS, we saw the same, 235 desktops, about 714 desktops, 714 login VSI base, and no VSI max reach. So in my opinion, if we look at these numbers, it means that we can run 235 3 vCPU Windows 10 desktops and still have headroom for more. And what that does to me is it fundamentally changes the discussion with partners, with end users. Because before it was, how many users can I cramp on this system? Because I want to be cost efficient. How many Windows 10 desktops can we land on this piece of kit? Now, all of a sudden, the conversation changes, because now we have to ask the customer, how comfortable are you with running 235 desktops on a single system? Right. The infrastructure can do it for you, but are you sure you want to create a failure domain that is that big? Or do you want to have smaller failure domains? You know, either way, it's fine by me, but it needs to be a conscious decision on the customer side of creating bigger failure domains, because if that one node fails, potentially you're losing 235 users. They might be calling your help desk, right? So it for me, it really changes the discussion from this is what it can do to what point are you comfortable of the system doing this?
So Kees, let me ask this question. So if you can see my screen, right? If I highlight this server that we used, right? If I just swap that out with similar Intel processors, am I looking at half the number of VDI?
Well, it depends, because Intel right now does not have an answer to the 32 core 2.9 gigahertz CPUs that AMD has. Mm-hmm. So if you look at current AMD or current Intel CPUs, if you go like in the 24 cores, they still have high clock speeds, but above the clock speed drops just because of the architecture of the CPU. Yeah. So AMD has a kind of a head leap towards Intel just by the CPU architecture.
Any idea how this impacts the price of the servers?
Pricing is not my game. That's where we have SCs. The good thing is that Nutanix carries specifically for end user computing a VDI core license, and that is to align to CVAD on Horizon, where you pay per concurrent user.
Yeah.
So from that perspective, it's probably interesting to look at when you're looking at end user computing, Nutanix, and the AMD systems.
And guys, I guess I missed this earlier. The key here is the number of cores at a high clock speed that AMD is able to get at this point.
Exactly.
All right. Yeah, that's the key part I was missing. Harvey, thoughts on any of this?
I mean, like Kees brought up, it just brings a totally new conversation to the customer, because the hardware can now do what we've always wanted it to do. And now it's a real conversation around making sure that they know what the risks are and they know how they want to address that.
So Harvey, how fast will your Tesla go?
As fast as I want to drive it, because I'm not going to drive it to the fastest it can go.
That's right. Because then that becomes
Creates other problems for you.
Correct.
No, I just think it's cool from an admin perspective, the kind of simplifying we can design for with other kinds of risk acceptance. Like we could have whole pod designs that maybe only need one AOS cluster per pod to even hit their kind of density targets, right? So then that's some wild simplification, wild density. That gets pretty cool pretty fast.
Yeah, it does. I mean, this is a big deal to those who are, still out there trying to find a good solution for them, who need some very dense hardware that can take a lot of users. Like, this is a very good solution for you. But again, let's have a real conversation around what risks you're willing to take and how many users you're willing to stack into a single box, because you're no longer constrained by the hardware. Now you need to be constrained by sensibility and budget.
Well, I made the joke about the Tesla, and that certainly has been a leap forward in terms of speed and not having a gearbox, that kind of thing. But look at almost any car for the last 10 years, maybe 20, had a speedometer that would register 120, 125, 140 miles an hour. And they would probably go that fast, but you didn't want to go that fast. It was
That's correct.
too much risk around what could happen if you were to drive that way, at least for most people.
Yeah, you're exactly right.
The whole windshield lights up red and blue. It's a feature, not a bug.
Yeah.
So Kees, this is great. I'm glad we did this, because I've had a couple conversations recently with customers around hyperconverge and AMD and trying to get more horsepower. And as a typical technology gearhead would be the person I'm working with, the customer, they just want to go as fast as it'll let them go. And this kind of helps me understand why they were coming at it from the angle they were with AMD and the need to go that route. So,
yeah, like I said, I think that there's going to be more leapfrogging. Although I do think that that AMD has a few upcoming releases that will put them a little bit further ahead compared to Intel. But overall, I think kind of the competition driving innovation is a great thing for us in the field, working with customers or as an end customer directly. The fact that you're taking away barriers in terms of infrastructure, but also from a software perspective, that means a lot to me, because I don't like to be fitted into one kind of way of architecting or designing. This gives you so much flexibility, so much headroom that you can easily kind of scale for the next foreseeable future when it comes down to Windows 10 releases, Office releases, and whatnot.
Yeah, I'm still really curious. I know we're technical guys here, and I got my technical hat on. I'm still a business guy though, and I'm really curious to see what these servers cost above and beyond your lesser core systems. I'm gonna have to check into that, but certainly just to know that the horsepower is there, and assuming it's not twice as much, that's a very compelling story.
It's even an interesting thing about, a design with a higher user density, maybe for DR, right? Maybe if it's a colo where you pay per rack unit, right? So you'll squish twice as many users in,
Right.
you know, accepting that maybe if you had an HA event, you have multiple departments affected worth of HA reboots at one time. But hey, it's only if it happens during DR, it's a double failure event. It's, there's risk acceptance there.
Yeah. No, it's
Yeah,
exciting.
more options is by far is a good thing to have.
I don't think I've had this conversation in like 10 years where we talked about processor speeds, AMD versus Intel. It's fun to go back and have this conversation.
Right.
Well, Kees, thanks for joining. Any parting words you would want to get out before we let you go, whether it's about this blog or anything else?
I think the most important thing for me, at least as closing words, is keep in mind that we've got reference architectures for all the brokering solutions out there. They're available on portal.nutanix.com. It's part of what my team does. Yeah. And if there's anything that I can do to help you, to anyone listening to this podcast, you can find me on Twitter, and I'll be happy to see if I can help.
No, that's great. I appreciate you joining, and we'll have you back just as soon as we see your next blog, and I'm sure it'll align with what we talk about, because Nutanix, end user computer, a big part of our day-to-day conversations. Jirah, any parting words for you?
I think it's exciting about the ability to, as we all get our hands on this, we always want to know what the applications are, what the end user performance expectations are, and we're almost sort of like advocating for the user of like larger VDI desktops, more resources equals better experience, but it affects density. And so having that equation change where I can have larger desktops without really having it linearly increase the solution price to the business, I think that's fantastic.
I just had a visual of a customer saying that, and Jirah goes and waves his magic wand and says, "Okay, there you go." I just don't know how much it costs. I want to know that.
Yep. So that's going to be my thing. Definitely give us a call, and let's price one of these out. Right, we'll get Jirah on the phone too. we'll make it a little group fun.
Well, actually, here, quick sidebar, right? You guys are a partner. Even customers have access to our Sizer tool, right? Like you can go design a live solution, and I think it even give you like a list price, so you can do an apples to apples comparison.
How dare you take away my fun?
He says that, but he's probably opening Sizer in like a background tab right now. So,
well, if I wouldn't share my screen, I would. Let me do that.
Yep.
Well, gentlemen, thank you very much. I appreciate you joining. Kees, I know it's late over there, but enjoy the rest of your night.
Will do. Thank you.
Thank you, guys.
Yep.